Welcome back to Do It Yourself Python series. In this video, we're going to look at how to build a statistical model to predict the future stock price, and also we'll be looking at how to add additional features to the input data and how to publish the model, and finally how to consume the model in a Python program. So let's go ahead and start building a model using Python. So here I'm looking at a stock ticker called XBIT. Right now it has $11.12. So I also filtered this data till December 5th. If you go to the historical data, you should be able to filter that, and then you can download the data. So throughout this example, I'll be using this stock symbol to show you how to build a model and how to add additional features and how to publish the model. So let's go ahead and look at the data, assuming that you actually downloaded this data and stored in a SQL Server. Let's go ahead and look at the data in the SQL Server. I actually stored all this data in the SQL Server. So all these examples are using the data from the SQL Server compared to the Excel sheets. So I have a table called stock, and which has a couple of columns: stock symbol, date, open, high, lows, close, and adjusted close, and also stock volume. And this particular table has all the data up to date till December 6th. But we'll be using only data till December 5th because we want to use that data set and create a model and use this data to train and test and see whether our predictions are accurate or not. So what I'm doing here is I'm using the SQL statement. If you execute that, I'll include this in the GitHub, and you can see the data from 2018 all the way till 2019 December 5th. So now we know the data and attributes of the data here. Let's go ahead and start building a statistical model so that we can predict future stock price. So I'm using Azure Data Studio to create a notebook so that I can show you the complete example in action. So the very first step is importing all the required modules, and there's pandas, numpy, and odbc and matplotlib, and also modules from sklearn for decision tree regressor and also linear regression, and to do testing and training we'll be using pre-processing and model selection modules from sklearn. And I'm also setting the PLT figure size to 16 by 9. This is to show you those graphs in a bigger size. So the second step is I'm setting a variable called days in future to predict. Right now I'm setting it only to 1. You can change this program to set it to any number you want, but you need to make sure that you test your data and then understand the R-squared factor. So the next step is connection string, because in this example I'm using SQL Server, and also, as I mentioned earlier in my videos, that you need to make sure that you have this driver installed on your machine. Next step is we're pulling the data from the SQL Server, the same statement I was showing you earlier, and I'll be using the same SQL statement here. And again, the stock symbol, we are restricting it to XBIT, and also stock date less than December 6th, which is all the data till December 5th. So when I execute this statement, I'll get a data frame with the data coming from the SQL Server. Let's go ahead and execute each statement from the start. So far no errors, which indicates that it was able to connect to the SQL Server without any issues. And now that the SQL statement is executed and we have data in the data frame, let's go ahead and look at the first few lines or few records from the data frame using this head method. You can see that the same data what we were seeing in SQL Server is also in data frame. But here we have stock symbol and stock date and all of the rest of the columns. We won't be using this stock symbol and the stock date in our modeling because it is a statistical model which looks at all the numbers rather than non-numbers in the data frame. You can still go ahead and convert this stock date into a number, but for this exercise we are dropping those two columns. The next step is dropping the columns, and if you notice that I'm dropping each column but again initializing back to the same data frame. So if I execute this and then again if I try to use a head method, and now you notice that these two columns are gone. So in the next step, what I was trying to do is that trying to add a new column called prediction, and for that column I'm trying to initialize the values coming from the stock adjusted close by shifting 1 day, because this variable has 1 as the value. So I'm just shifting all the values 1 day above. So if I execute this and then execute the df head, now you notice that there is a new column called prediction, but all the values from the previous day or the next day is actually showing up in the current day. So 410 here shows up in the very first record, and the third record value shows up in the second record. Basically what exactly we are trying to do here is that if I pass all these values in the second record to the model we just developed or we are going to develop, and that model should be able to predict around 4.12, because we know that the next day it is going to be 4.12 anyway. So that is the prediction value here. This is just to show you that we can use certain commands like shift to really play with the data frame. The next statement is I'm trying to see, because this head is showing only the first 5 records, I just wanted to see what is the last values in the data frame. So I'm just using tail of 6. So it's basically we are trying to see the last 6 records in the data frame. And if you notice that the number of records here it's showing as 485, but because it is a zero based index it is 486, the same number of records we saw in the SQL Server. But the last record, if you notice, there is NaN value, which is a null value, because we shifted everything in this column 1 day above, so that there is no value for the last record. Okay. The next statement is describe. This is a very powerful method which gives you an idea on how all this data is related, not the values. So if you execute that df.describe, and now you notice that the number of columns are the same, but right now it is showing you some different information, not the values. So the count, which is 486 number of records, and mean, standard deviation, min value, and 25% of the distribution, 50% of the distribution, and the max value, and 75% here. So the max value is like based on our data, which is like 486 records, max is 14.8, whereas mean is 6.44. And if you closely notice that all the columns till prediction they have same the number of records, but for the prediction column it's using only 485. That's because it's automatically this describe method is dropping this record NaN because there is no value and there is no value for this particular calculation. So it drops it automatically. So that's one interesting thing about the describe. And you notice that there is a slight difference between the mean and here, right? Because all the values from the stock adjusted close, those are the values we are using for the prediction, but slightly shifted up. So the next statement is I'm just dropping any values which are nulls, and then again after dropping those null values, again if I click describe, this time you notice that it's showing 485 records here. That means it's completely dropped the record from the data frame, and now you can see that all these columns they have 485 records. But if you pay attention to these mean values, they are also changed slightly. See that the mean with the 485 records is 6.43 compared to 6.44 with the 486 records. And the next step is go ahead and execute this df.tail last 3 records, and see that the last record with the null value is gone now. So our data frame has all the records with all the values. There is no record with any null values. So at this point I just wanted to visualize how exactly it looks if there is a linear relationship between stock adjusted close versus prediction, just for the visualization purpose. So we can't really make out anything from this scatter plot, but it gives an idea that both values are pretty close, right? We may not be really using this figure for any exercise, but sometimes I would like to visualize and see how this data is related. That's for a simple example. The next one is what I was trying to do is that now we have 2 columns in our data frame, and I just wanted to plot those values and see how they are actually related. The next step what I was trying to do is trying to plot these 2 values from stock adjusted close and prediction, so that I can visualize how these 2 are related on a plot. This is not a scatter plot, this is just a plot. And the red is stock adjusted close and the prediction value is shown in a green color. We may not be using this information in building a model, but again sometimes you need to visualize your data to see any kind of pattern. The next step is I'm actually initializing all the values from my prediction column, which is a derived column, into a variable called x. You can name it any way you like it, but it's easy to understand if you use x and y. So, but I'm using NumPy array to convert all the values from the data frame, but just dropping the prediction. And after this, if you look at all the values in x, and you notice that they are not like values what we saw in the data frame. So this is everything is now converted into an array, and if you want to know what exactly that array type, you can use print type x, and this is nothing but numpy nd array. I would recommend you to go through this nd array basic concepts, because arrays are the most important thing when it comes to building a model. So now x has all the columns from the data frame, but a prediction column is removed from it, because that's the uh, value we'll be using in the modeling. And let's go ahead and check how many records are in X. 485. And if you remember, we use this statement to drop any record with null values, because null values will not help in building a model anyway. 485 records in X, and when you try to again describe data frame, it still shows 485 records. And now the next step is we are trying to initialize all the values from prediction column into a variable called y. And if you look at the values in y, right now you can see that there is a values array values here. And if you look at the length of it, again 485. So we have 485 records in X and 485 records in Y, and Y only has one column called prediction, whereas X has the remaining columns. So here what I'm trying to do is that I'm trying to create a couple of variables, which is called train X, test X, and train Y and test Y. And I'm using this module called model selection. This is what we imported from sklearn. And there is a method called train test split, where you can pass all the values from X and Y. Remember that X has 485 records with a couple of columns. Y has 485 records but only one column, which is a prediction. And in this case I'm using a test size as 0.2, which indicates that it is 20%, and random state I'm setting it to 0. I'll explain these things later in detail, but let's focus on these variables and how they work. So after I execute that statement, what we are trying to do is that we are trying to split those 485 records into two sets. One is with 80% of the records, other one is with 20% of the records. So now if you look at the length of train X, which is 388, which is 80% of 485, and if you look at the test X, 97, which is 20% of this 485 records. So what we are trying to do is we are trying to create a model, and that model can learn from looking at the data in the train X variable. This is called supervised machine learning. What we are trying to do is that we are trying to provide all the data the model requires so that it can learn from it. I have to correct this spelling mistake here. But anyway, let's go ahead and look at all the values from train Y, 388. So for both training exercise, values in both train X and train Y are 388, right? You can split this into 50-50 or 30-60 or whichever percentage you want. You can split that, but you just have to mention this value from 0 to 1 factors. 20 indicates that 20%. So your testing is 20%, but your training is 80%. Okay. The next step is we are using a scikit. The scikit is very powerful. It has a lot of regressors you can use, but for this example I'm using a decision tree regressor, and I recommend you to go through the basics on decision tree or linear regression, or maybe other regressors where you can use to model to create your model. So here I'm declaring a variable called stock price predict model. That is a variable I'll be using in the next steps. I'm just initializing with the decision tree, and the next step is I'm using that model object here, and I'm using a method called fit and passing the train X and train Y. Basically I'm passing all the 388 records as X and then 388 records in Y variable. So what this method is trying to do is that it is trying to figure out, like, using this values in the X and using the values in Y and coming up with the best coefficient of determination factor. That's what exactly this fit is doing. But that is just trying to fit the data there. But we still need to understand, or we need to really see whether this particular model is actually giving the best score. So again, as I discussed in my previous videos, the most important thing in the modeling is to get a best R squared factor. So I declared a variable called R squared factor. Let me remove that E, and I'm using this model we just created because it's already trained using these two variables. So I'm trying to score using the score method, but this time I'm not using the train data set, which is 80%. I'm using the test X and test Y, which are basically 20% of the data, which is 97 records on X and 97 records on Y. I'm using multiplication factor here 100 to just visualize the percentage. So here, after I execute this block and try to print R squared factor, it is right now showing 95, which indicates that it's 95% accurate. Your main idea behind the modeling is to get this to 100%, but in real world it may not be possible, but there are scenarios where you can actually bring it close to 100%. And the next step is I'm using the same model we just created earlier, but this time I'm using a predict method, but I'm passing a test X values, the same values what we just passed here to score, and a variable called all test prediction here. And in my next step, what I was trying to do is whatever is actually sitting in the all test prediction, I'm trying to use those values and print it along the test Y values, so that we can compare what is exactly in test Y versus what we actually predicted. Again, I'm using the same data set. So after this block is executed, I'm trying to print those values. These are all the values which are in test Y, which is 20% of the data. But all the values now we just created using this predict method are in this second column. With the 95% accuracy, this is how our model performed. If the value is 4.99, its prediction is 5.46, and again 9.78, 9.61 here, so they're pretty close. 8.48, and again it's predicting as 8.59. So you can fine-tune this model, and as I said, you can bring this model to more towards the 100% accuracy. And our next step, what I was trying to do here is that print both values from test Y and whatever was predicted using that test y values. So if I click this block, you can see that I'm printing all the test y values, which are nothing but again 20%, which are 97 records. I'm trying to plot them in blue color, whereas all the predicted values are in red color. And you can see that our model was trying to almost predict values pretty close to the existing stock adjusted price, but in some cases it was not able to predict accurately, and that's what the 95%, and that's what exactly made this line, the red line, not to predict close to this existing values. But it is pretty close because all the values are almost like matching with what we predicted. And this plot is also showing any kind of misses at the prediction level. So I think this area is where it was not able to predict accurately, but you can fine tune this model. So now the next step is, I'm happy with this model, let's say at the 95% prediction accuracy. So now I'm going to apply this in a real world scenario where I was trying to get select top one from the same table again with for the same stock symbol, and again the date is 06, but this time I'm trying to order the data by stock date in the descending order. So what exactly I was trying to get here is, if I run this statement in SQL Server, I'm getting only one record, which is the last record, because that's what this trying to order by descent is doing, and again for the same symbol, and again less than 12.6. So now I have just only one record, which is the latest record on December 5th. So if I execute this and look at the head, and now I have this record only one, and then again remove the stock symbol and the stock date because we did not use those values, those columns in our modeling. And again if I go and execute the head statement, and now I see only stock open, high, low, close, and adjusted close with the stock volume. And the same steps what we did at the time of modeling, I'm repeating it, but only for one record. So now I'm using that one record as my input to predict the future stock price. So this is what that exactly is. Input X, I'm just converting this one record into an array, and now you can see that the input X has all the values. The only one thing you need to be aware of is that the number of features you use in the modeling, and you have to pass the same exact number of features when you're trying to predict also. So that's why we needed all these columns. Now that we have all the values from that one record is converted into array, and inside this input X variable, I'm passing that input X variable to the model, but this time I'm using the same predict, but this time I'm storing that value in a variable called future stock price. If you click here, and based on the last closed trading, we have the last record because that's the only information we can use to predict for the future price. So when I click here for the future stock price, it is showing 11.62. So let me go back to this one, the price, and the price on December 5th, right, is 11.02. 11.02 what we have in our database. Now going back to this Yahoo Finance again, let's go back to summary and historical prices. Now this time I removed the filter, or you can see the value here. On December 6th, this particular stock symbol XBIT is closed at 11.12, whereas our prediction says it is 11.62. This is because our model accuracy coefficient of determination factor, which is also known as R squared factor, is 95%, right? So it's close. It is not exactly matching with what we have on the actual, the Yahoo site, but it is pretty close. So I hope you understand all the steps involved in building a model. This is a very simple exercise, but it can get complicated because sometimes you may be dealing with not 485 records. You may be dealing with a terabyte or a petabyte of data, so this will take long time to execute, and then you may have to adjust your test percentages versus train percentages, and you may want to reshuffle the data inside the data set so that you can get a better R squared value. So there are other methods you can apply to improve your model, but if you look at all the steps, it's very simple. First, you get the data from wherever the source. It may be an Excel sheet, a SQL Server, or maybe a cloud database, and make sure that you understand all the columns and drop all the columns which you don't need, which they don't have any statistical significance, and you can drop them right away, or you can convert them into some numbers so that they'll make a difference when it comes to the statistics. And then again, using this describe method, you can visualize how this data is actually related and what is the basic information about, like count, mean, and how the distribution is, and what is your max value you're dealing with. And then again, there are some steps where you have to remove null values. You can use a simple method to do that, and plotting to make sure that you understand the relationship. And this is not giving us any good idea, but sometimes you can visualize the data and see how they are related. And there are some more plots you can visualize again. And the next step is that trying to define what exactly you want to have in X axis and what exactly you wanted to have in Y axis. The X is independent variables and Y is always a dependent variable. But in X you can have one feature versus many features, but you need to make sure that you are using the right features, because you have to pass those features at the time of prediction as well. And the other step is that you are using this train test variables basically to train your model so that it can understand the data very well, and then immediately you can apply that learning on the test data to see whether it is performing well or not. And again, there are only few lines of code to develop a model, but because this is a simple example, but in other cases you may have to add more complex statements to fine-tune your model. And R squared factor, I think this is the most important thing, and this will give you a confidence level. And then you always want to test against the test values to see and compare how your prediction versus the test data. Because that will give you a clear idea on how this model is performing, and some more visualization to see how your prediction versus the existing values. And once you're ready and once you're happy with your model, then you're ready to really test it with the values like the features what you actually use in the model building. And prediction here is also simple. You're going to use the model and use the predict model and just pass the values. Again, those are called features, and you get the value and then see whether that value is actually making any sense. I hope you understand, and I'm using this Azure Data Studio, and you can use Jupyter or you can use other cloud-based tools like Colab, but the basic idea is the same. And you just wanted to develop a model, at the same time you want to visualize it, and then you want to test it and train it, test it, and then fine-tune it. So my next example is to add additional features to the data set. So let's go back and look at the data set, input data set. Yeah, this is where we got all the data from the SQL Server, but this data set has, I think, 1, 2, 3, 4, 5, 6 columns, right? So, and then again, if you look at the stats for that particular data, which has this mean value and the max value are defined, and this is the information it is using to really predict, like. So how do we improve this particular stats for the input data set? So I created another notebook, and I'll be publishing these notebooks on my GitHub, and you can download it and you can use it straight away. But I created another example on how to add new features. So let's go back to the SQL Server. Here what we have is the same number of columns what we saw in the data frame, but is there a way I can build an additional feature using these existing columns? And it will helpful in building a more accurate statistical model, right? Because the more numbers, and it will be able to learn from those numbers and then improve that R squared value. So what I was trying to do here is the very first record, if you notice, this is on Jan 2nd. The stock volume on Jan 2nd is going to be the stock volume for Jan 3rd, but if I can create a new column called previous day volume, right? So I wanted to see this number on the side for the second record. So what that means is that now I'm able to build a new feature called previous day stock volume. So if you are using data frame to achieve that, you can use the shift the same way what we created for the prediction. But in SQL Server, what I'm going to use is the lag function. So I'm selecting all the columns, but the next column is like using lag on stock volume, but I wanted to go back only one day and just show it null if there is no value. But again, over order by stock date, and I'm just naming that as a stock volume day -1. Let me execute this and show you how exactly this lag function works. See that I'm able to define new additional features deriving from the existing columns, but adding more statistical value. The value means right now you see that this 450 450 20 value is showing up in the -1, which indicates that if I'm looking at the record for Jan 3rd, now I know that the previous previous day volume is available for me, but when I went to the -2, I don't have that information here, and when I went to -3, I don't have that information in the third record. So what happens is when you do the drop null values, these three records will be dropped because they don't have any significance from the stats point of view. But I'm still able to build additional features because we don't know whether this volume is actually affecting this stock adjusted price. And if you scroll all the way down, you have that because this is the data we are looking at from 5th going back to 2018. Right now you can see those values are showing up. Only the first three records we're going to miss from a stats point of view. And you can build additional features because they may be correlated. We don't know if there is an existing hidden pattern where the volume is always affecting the stock adjusted price. So you can technically build how many columns you want using this lag function going back to the previous values, but you also need to keep an eye on whether they are going to make any difference when it comes to the stats, like standard deviation, median, and then min and close, the max. Okay, so going back to Azure Data Studio. So here in my second example, all I did was that added additional features, and I added these additional features to see if it is improving my model. Everything is same, only difference is that we are bringing in additional features. Again, those features are derived features. They don't exist, but they do have some kind of relationship. So let me execute the entire notebook to see any change in the R² factor. And if you notice that now you have more values, and as I told you that we will be losing those three records. Now we lost those three records because they have null values, but again the mean and standard deviation and the distribution is slightly changed. Let's go back to the previous notebook and see that this is 485 records, 6.43. Even though we lost our records, the mean is now 6.45. And let's see if that actually affected our R² factor. And R² factor right now it is showing as 95.699. Go back to the previous notebook. It is showing as 9.51. So it is slightly improved, even though the improvement is in the decimal places, but it is definitely improved. It's slightly improved, but the main point here is that you can add additional features deriving from the existing data or existing columns so that you can improve the statistical significance of those values, right? Because they are somehow related to that adjusted price, and all these values are playing together to come up with that prediction. And example what I was showing you here is that you can simply use a lag function where you can use a shift function in on the data frame to achieve the same thing, but I would like to see all the values in the SQL Server. Maybe I can persist this data in a table called analytical base table, and that is also one important topic. But the more number of features you add, and you need to be aware of one fact that you may be losing some records for the analysis, but you will be improving your model with the new additional features. So in my third example, instead of showing this SQL statement on SQL Server, I just wanted to show you that SQL statement in Notebook itself. Apart from stock volume -1, -2, -3, I also added another feature called previous day adjusted close value. So that's this statement. So we have stock volume -1, -2, -3, and I also added another feature called stock adjusted close -1. I'll be still losing these 3 records, but I'll have more connection between these values from the stats perspective. So let's go ahead and use this SQL with additional features. Now we have additional features like 1, 2, 3, 4 compared to 3 in my previous example. So that's what this statement is. I'm building the statement, SQL statement here, and now I have additional 4 features, and let's run this entire notebook and see if our R squared value is improved. And R squared value is now 96,769 compared to 95. So I hope you understand the importance of features, right? And if you are starting your model with only a few set of columns, and you will notice that by adding additional features, your model prediction accuracy will improve. And not in all cases, because you just can't add features because the you can use the lag function. You need to understand why you are adding it and how it is actually going to affect your prediction. But there is always a relationship between these numbers. You need to find that out. Let's see how our exercise 3 predicted the value, which is it's showing 11.33, and example 2 is showing 10.91, and example 1 is showing 11.62. So there is a variation between this prediction. Again, it depends on how much data you are using to train and how much data you are using to test. Sometimes you can change the percentage and you can fine tune your model as well. Now that we know how to create a model and how to train it and how to test it and how to predict, the next step is that how do I distribute this model so that my business users can use it. And majority of the cases, you may be focusing only on developing the model because you understand data and you understand how to train and what regressor to use, and you understand what the R squared value mean, and you understand the accuracy of it, right? But you need to give this model to your business users so that they can actually use it in their daily job. And you may not be actually predicting based on some data. They are the ones they want to predict it, right? They are the ones they want to use this model. How do I do that? So I created another notebook just to demonstrate that. But this time, if you notice, I'm using a module called pickle. This is a part of Python. You can use it, and everything is same. I'm happy with the R squared value, let's say that, and I'm also happy with the prediction, let's say that. Now I know that my model is actually in this variable called stock price predict model, and if I'm able to distribute this model to my business users, and that will be useful for them, right? So how do I distribute that? At the end of this notebook, yep, I'm using this pickle module. So I declared a variable called model file name, and I'm planning to save the model what I developed into this file called a file named stock price predict model, and with the extension of SAV. And then I'm using this module just pickle.dump, and the model, this is the variable where our model is right now, and I'm actually saving it to this file. So just clear everything. Let's run this entire notebook and see what happens. No errors. So the file should be created in this folder called data.py, and with this file name. Let's go ahead and check that. See that we have a model file sitting here called .sav. Let me open that. Notepad. This file is something like a compiled file, where using Notepad we cannot read anything from it. So this is how you can actually generate a file with the model you just created, and you cannot simply read it using Notepad, and you have to use Python to read that model. But right now this model is generated, and it is now available in this particular folder. In a real world scenario, you may be publishing these models in a network file share with the version number attached to it, because sometimes you may be developing a version 2 but you still don't want to publish it, or you don't want your business users to use it, and that's how you generate the model here. So our next step is, now the model is generated, and it is right now saved to a file share place, or maybe a particular network file directory. But as a business user, how do I use this model? Let me go ahead and show you how a business user uses this model to come up with predictions. So I'm using Visual Studio. You can use Spider, or you can use Visual Studio Code, or you can use PyCharm, and a lot of tools, right? Like you can use those tools to create a Python program, but in this case I'm using Visual Studio Community Edition, and I'm using this Anaconda distribution here, and this is my solution, and this is the Python file I just created, and this has some comments just to give an idea. And again, same import statements, but this time I'm not importing any sklearn, because I don't need that, because this example is from an end user's perspective. So I created this module with all the libraries I need, and I'm using system arguments because I'm going to use this from the command prompt, and then again I'm connecting to the SQL Server, and again to pass the X values I'm only taking one record, which is the last record from my stock table, because in our last example we used 4 additional features and they are included here as well. But whatever arguments I'm trying to pass here is actually stock symbol. So if I pass XBIT, that XBIT will be this dollar will be replaced with that symbol. And you can change this statement and you can come up with more sophisticated input and output logic, but this is straightforward. So when I execute this module, I'll just simply pass the stock symbol, and that stock symbol is used inside the SQL statement, and then I'll get the last record from the SQL Server. So this is my statement, and I execute that statement to get a data frame, and again I'm dropping those stock symbol and the stock date, and you can drop them directly here so that you don't have to do this step, but for this example I just wanted to show the same steps what we used in the model building. So once that 2 columns are dropped, again same, we're converting that last record whatever is in the data frame to an array, and I'm going to use that array as my input variable for the predict model. But remember that in our notebook we had access to that model variable so that we don't have to really do anything. But in this scenario we need to load that model from this so-and-so file using again pickle module into variable called stock price predict model. So this is where our model is right now, and which is initialized, and I'm using that object here and use the predict method and pass this input variable there, and then I'm just printing the stock price, and I can simply handle this errors using this try and except block. But anyway, this Python file is generated using Visual Studio, and then I'm not going to use the Visual Studio every time to run this module. So how do I do that? So as a business user or as an end user, I have this module, the module which we just developed in Visual Studio. In that module, I'm actually loading the model which we developed from previous exercises. So how do I make a call to that? So that I'm using this Python command. If your Python is installed and if all environment variables are set properly on Windows machine, and you should be able to call Python from any directory, so I don't have to worry about going into this Python installation folder. I can call Python from anywhere. So this is the first statement, and I'm passing this module. This is the module we developed in Visual Studio here, and then I'm passing the variable called XBIT. So how Python arguments, how they work is that this is the first argument, which arguments as 0 here, but my stock symbol value is actually coming from second argument, so which is 1 here, because they are 0 based. So if I run this statement, this module is actually executed and made a connection to the SQL Server, got the last record and converted that record into an array, and also it actually loaded the model we developed and saved in this model file, and it was able to use the predict, and it came back with a value 11.33. I think the same value we were seeing on Yahoo Finance page. Let's go ahead and check that. Yeah, this is now 11.12, but whereas our prediction is saying 11.33. As I said, you can add additional features, you can fine tune it, and you can use different regressors like the addition tree or linear regression, whichever suits your particular data, and then test it, train it with large amounts of data, and then publish it, and so that the users can use it. I hope this complete example, end-to-end example, gave you some information on how the entire modeling works and how to publish and how to use it. If you have any questions, please let me know, and I'll include all the links, and I'll be uploading all these files to my GitHub. And if you get a chance, please do subscribe to my channel, and it helps me to create more examples. Thank you.